Good morning. Now we are going to see the DCS loops and its programming and real-time operation. So in this we can see that we have the index. So in this index we have all the loops, level, flow and pressure control loops. So these loops are connected with this real-time setup, which you might have seen in the earlier video. So now we want to see the overview of this particular loop. We can take this particular overview of this particular loop, and this can be so what we are doing is we are having this process loop. So when you take this loop, we are having 3 loops are in this system. So these 3 loops are nothing but we have the level loop where the water is taken from the reservoir, which is sent to that pump. This level pump will be working, and this level pump is feeding the water to a stainless steel water tank. So there is a safety valve which will be bypassing the water so that we may not affect our pump. Then that from the water tank the level is taken as digital signal through this differential pressure transmitter, that is a level transmitter connected in here. So now we want to maintain level in the water tank. We are giving a set point of 25 centimeter. If water level goes above 25 centimeter or comes below 25 centimeter, how we will be controlled? So that can be control operation can be done through a level control valve, and the water will going to the particular reservoir. Second loop is nothing but the flow control loop where the water is taken, so which is through flow pump. There is a safety bypass water flow. Then we have a orifice plate. Before and after orifice we have the feeds, so that feeds are taken through a differential pressure transmitter. So from this the water is going to the main tank. So this also the water flow is maintained through this the final so this is a control valve. So the control valves are getting pneumatic supply from these I2 pi converters, which are connected from the DCS. So 4 to 20 milliamps current will be coming to up to this I2P converter. This I2P converter is supplied with 20 psi compressor pressure. So that pressure will make this final control valve to open and close. The third loop we have is the pressure loop, which will be taking the water from this tank. We are using a pump. Then we have a pressure header. So here the pressure is made. So that pressure is measured through the level transmitter. Measured through a pressure transmitter, which is a differential pressure transmitter, and this pressure can be met through the control valve. The outlet of this pressure it is controlled through this control valve. So we have the I2P converter, which is converting the water flow controlling the pneumatic air going to this particular control valve. So when you come to when you take the operation, when you double click this pump, so the pump on off condition will come. So when you double click this pump, that pump on off condition will come. So whenever we want to start any pump or things, we can double click the pump diagram in the overall control system. So that pump phase plate will come. We might have seen what is phase plate. So this is a pump phase plate coming. So you can run the pump or you can stop the pump through this phase plate. You can see the indications the pump is running or not. So this is how is the overall diagram of the particular system. So this is in another one pump which is available here. So this is about the overall system. Now we want to do only any one loop that we will take. So let us go to level control loop. So we will double click here. So we will get the level control loop. Now we have taken, so here you can see all the loops are available, right? But now we are taking only one loop. So this is the level control loop we have. In this level control loop, what we are having, water reservoir is there. We are taking water from the reservoir. We have the pump, right? This pump is used to pump the water to the particular tank. So tank is having a level gauge, which is a manometer. The tank level is measured through this level transmitter. Now how will you maintain the level in this particular tank? By this control valve, which is sending the water outlet from this particular tank. So by I to P converter connected from the DCS, we will control the valve operation, and the level inside this tank can be maintained. So in order to avoid any impeller problem in the motor pump, we have a bypass valve also. So now you want to have the faceplate, that is control drawing of the pump. You can double click the pump, we will get the faceplate of this particular pump. So now we are going to do the process, real time process. So we have taken the level process, we have taken level from this front diagram. Okay, the level loop came. Now we will double click the pump. So we will double click this LIC 100, that is level indicator cum control, and we are taking the pump. So both things are there. One is we have to switch on the pump, another one is we are going to see the control operation of the process. So you can see we have a PID controller faceplate, we have a pump controller faceplate. So this is to switch on off the pump. This is for the process diagram. So where we have process variable, manipulated variable, set point variable, we can give the input. So there is a one thing you can see here, it is manual, MAN is there. So it means this is manual mode. So we can, when I double clicks this manual mode, we will get three things. One is manual mode, auto mode, and cascade mode. Three kinds of modes of operation we can do with this type of PID. So when I put in auto mode only, we can give the set point, all these things. Now I am changing this to auto mode. So now we will be changing this to auto mode. So there is a problem, this is in operator mode. Let me change to engineering mode. So I will change to engineering mode. I will again come with this new loop. So now we are coming. I change to engineering mode. Now you can see engineering user. So I can change to auto mode. Now it will ask whether you want to do the engineering user, you want to do auto mode or not. Now we move to auto mode. We have given a set point of 30 centimeter. Now the level is 0 centimeter. Now I am going to change the set point to a different value. Let me use some 20 or 25. Let me give 25 as the set point for this particular system. When I give the 25 centimeter set point, now the process set point is changing to 25 centimeter. And when we start the pump, then the process starts to work. Okay, so we are giving set point through this. Going to do the real time experiment of level control system. Now we are going to switch on the level pump. So we have given already 25 centimeter set point. We can see that water is coming to the tank, process tank. You can see the sound, and this is the pressure transmitter which is used to measure the pressure, so that you can see the level measurements. Okay, so we can see that level is getting raised in the indicator. You can see that water level coming up. So we are given 25% as the set point. We can see that water level coming up in this glass tube indicator. There is a manometer we have. So based on the level changes, you can see that the current coming out from this particular DPT is changing. So this DPT is connected with the DCS, so that we will make control actions, and flow to this particular control valve is particular station is controlled, right? So the control valve is so this we are getting water level getting increased. We have already given that 25 centimeter is the set point. So you can see the valve action here. So when our water level is reached, so this valve action will change. So we are having the control valve in the outlet of the tank. So you can see an RMR coming, right? This outlet is coming from our output of the tank. So this output will be coming through this control valve. So you can see the valve action changing. So this valve will be closing because of the level rise in the particular tank. So we are expected to maintain a 25 centimeter level. Since we have implemented PID controller in this, you can see this control valve closing, and now it is open, so that the water level goes above. You can see that water level goes above our set point. So we are already aware that whenever you use a PID controller, there will be a change in height. It will come, then it will take action for so now above that water level, that water will be dispensed, and we will be seeing that program how the trends are coming from the computer window. Now we are going to see the level control operation. Now the level is running. You can see that we made the pump on. Now the pump is turned on, water is coming to the tank. Okay, so pump is turned on, the water is coming to the tank. We can see that. So this water is getting increased. We have already given us 25 centimeter as the set point. Since tuning parameters may differ, kpk, that is proportional gain, integral time, derivative times changes, so this may not happen. So you may have this may exceed, and again it may come down, like PID responses we have seen. So it is it reached 30, 36 now. So when we change, we can also change the tuning parameters with this particular system. We can see that this output is coming. So now we are going to see how we can change the tuning parameters. You can just right click on this LIC control operation. So when you right click, you will get a tuning window. So in this tuning window we can change the tuning parameters values. You can see we have the values for PID, what is the P value, what is I value, what is the D value. So these values can be changed in order to properly tune this system. So this values we are changing, and we are going to get the control operation. So we want to say this is the KP value we are going to change, and we are going to get. So now when we are going to use this system, we can say that we are going to change the parameters values here, and what we will be getting is nothing, the trend, that is the graph of the PID controller output coming. So we can change, we can use this graph for our purposes. Okay, so now you can see that level is coming down and reaching the set point. So we can take also the data in terms of Excel files or data. So now that we are going to see how we are going to take the data. So here you can see a clipboard copy that is there. So you can right click the window and you can get the clipboard copy. So in that data is taken, and we can store the data in an Excel file. So we will get the data in terms of time versus these readings. So this can be used for further processing, making graphs, all these things. So now we will see how we can make simulation for readings. So what we are going to do, we are going to use this PID tuning online resource, so that we can take the readings for this particular thing. So this we can change our set point. The set points can be changed here. So if we are taking for 25 centimeter, then we can change the set point, right? We can make auto tune of these parameters. So you can auto tune and you can get the readings. So these readings you can use, and you can take the snapshot of this component, and you can place it in your Word document, and you can submit. You can start, you can stop, and you can start. All these things you can do. You can change, you can make auto tune, you can change the parameters, gain values, and you have to take the readings for each all the experiments, and you can submit this.